Good morning. Mr. McGregor, we're ready to begin with your witness for today.
Yes, my lord. The next witness is Mr. Andrew Poplett.
Good morning, Mr. Poplett. As you appreciate, very shortly going to ask Mr. McGregor to ask you questions. Before then, will you take the affirmation? Sitting where you are, I can ask you to words after me. I solemnly, sincerely, and truly
I solemnly, sincerely and truly
declare and affirm
that
I will tell the truth,
I will tell the truth,
the whole truth,
and nothing but the truth.
Thank you very much, Mr. We will, sitting from 10 to 1, but we'll probably take a break about 11:30 or so. If, on the other hand, any time you want to take a break, evidence, just let me know and we can take a break. But now I invite Mr. McGregor to begin questioning.
Are you Andrew Peter Seymour Poplett?
Yes, I am.
And you've provided a witness statement to the inquiry dated the 13th of April 2022, is that correct?
Yes, that is.
That's found at pages 97, 139 of Bundle 6 and the appendix at pages 141 to 143. Am I right in thinking that that statement addresses health technical memorandums that apply in England and Wales and associated guidance?
Yes.
Together with setting out your knowledge of design, installation, commissioning and validation of systems in hospitals?
Yes.
The content of your statement will form part of your evidence to the inquiry. You're also going to be asked some questions today. If you do want to refer to your statement at any point, please do just let me know. Mr. Poplett, if I can begin with your qualifications and experience. Are you an engineer?
Yes, I am.
And are you an incorporated engineer registered with the Engineering Council?
Yes, I am.
An associate member of the Chartered Institute of Building Service Engineers?
Yes.
And you're also an affiliate member of the Institute of Fire Engineers?
Correct.
If I can ask you just to look within your statement, the Appendix 1, so that's in page 141 of Bundle 6. You see that at the top, resume of Andrew Poplett.
Yep.
And we see a summary of your employment history. So you trained and qualified as a mechanical building services engineer. Then you set out your employment from September 1985 to September 1991. With Haddon and Young Limited. Can you just explain what were you doing at your time with Haddon and Young?
I was principally employed as a building services engineer, and throughout my apprenticeship I was cycled through the various departments within the company of design, estimation, planning and installation supervision.
And what types of projects were you working on?
A whole range from industrial, commercial and some healthcare.
And then in 1992 you moved to Newcastle General Hospital, is that right?
Yes.
And then for that period, essentially from 1992 until 2010, were you working for various NHS trusts?
Yes.
And can you just explain to the inquiry, what did your work within those trusts involve?
At different times throughout that period, I was initially recruited as what was then known as a works officer. Very shortly after I joined, it became an estates officer. I had responsibility for specialist engineering services, predominantly ventilation, as well as Legionella control within the Newcastle General Hospital. Through various mergers and NHS developments, I rose to the level of assistant head of estates and for a brief period acting head of estates before leaving that trust to join another trust, the Northgate and Prudder Trust, as head of estates.
If I can just be clear, whenever you're saying that you acted as an estates officer, what's an estates officer doing within a trust?
An estates officer is an operational manager who looks after and runs estates issues on behalf of a hospital.
And you mentioned ventilation, but is it a wider remit than just ventilation?
Yeah, estates officers will cover all aspects of both building and engineering disciplines.
And you mentioned that eventually you became head of estates for one of the trusts. How does that role of head of estates differ from simply being an estates officer within it?
As an estates officer, you are directly involved in the day-to-day management of, in my case, mechanical engineering services. As a head of estates, you are, if you like, one tier up and looking after other operational estates staff under your management for the delivery of the estate service.
And you mentioned that you're really looking after engineering and, in some aspects, ventilation. At a practical level, what does that involve?
That's a very wide question. It can be as simple as ensuring that maintenance activities are undertaken appropriately and completed, up to design reviews or involvement in the development of new projects, through to the supervision of those projects and commissioning, and indeed the decommissioning and closing of systems down. In my particular case, one of the largest single schemes I was involved with at Newcastle was that the trust had one of two national centres for bone marrow transplant or SCIDS babies born with no immune system. Ventilation systems within that facility play a key role in keeping those patients safe, and I was involved from its construction as the client supervisor through to its operation for the next 7 years.
If I can just ask you a few questions in relation to that. You mentioned that in your role you could be involved in design issues, is that correct?
Yep.
So you can just explain what do you mean by being involved in the design stages of a ventilation system?
Generally speaking, if it is a large complex design, there will be specialist design consultants and engineers engaged within the project. An operational or project estates officer will monitor that design. They will review it to an extent without taking design liability for it. In a more basic approach, if someone puts a new toilet facility in and it needs extraction installed, project officer would not normally get a designer involved in that level of project and would design a system that was compliant and suitable.
So am I correct in thinking from what you've said that the client, so the NHS trust, the estates officer would have direct input to an external design team, is that correct?
Normally, yes.
And can you just explain to the inquiry what level of involvement the estates officer would have?
It very much is governed by the nature of the project and the level of input that any individual has or experience they have. So it's more clearly clarified now in the role of what is termed an authorised person.
We'll come on to discuss some of those technical terms in due course, but at the minute you mentioned in your roles as estate officer and head of estate that you'd be involved in design. You also mentioned that you would be involved at the construction stage of a ventilation system, is that correct?
Supervision or observation of installation, yes.
And it's obviously obvious to you, but what do you mean by that observation or supervision?
Site inspections, make sure that what was designed and drawn is actually what's being installed.
And you mentioned you'd also been involved in maintenance issues. So what type of maintenance are we talking about if you're either the estates officer or the head of estate?
As an estates officer, you would look at what levels of maintenance were appropriate for the installation. You would make sure that suitably competent individuals were assigned to complete that maintenance. If there were breakdowns or reactive works, then you may be asked to come in to do investigation or fault-finding works in support of the competent persons, and you would make sure that the maintenance got delivered. As a head of estates, you have a wider or a broader remit to make sure that all of the relevant maintenance for all of the different engineering disciplines gets delivered.
And again, I'll come on to discuss this in greater detail, but you mentioned the term being involved in commissioning. You just explain in very basic terms what you mean by commissioning in the context of a ventilation system.
Commissioning is a process whereby you balance the system to make sure that the correct distribution of air is achieved through all of the outlets or inlets have been delivered and designed, and you make sure that everything functions properly and appropriately. So things like fire dampers are functional and operational. Fans are in balance, they're drawing the right voltage, the airflows are correct, and they are appropriately proportionally balanced. After commissioning then comes the stage of validation, which is ensuring that all of the different engineering disciplines that interact with one another all work as they should.
And again, would it be an estates officer or a head of estate that has a role, some form of role in that process?
During my time, bearing in mind we are talking 15 years ago, yes. Today, it would be an authorised person.
So if I could return to your CV, please. So that's page 142 of bundle 6. You mentioned there that from May 2009 onwards, that you've now set up as a company called Andrew Poplett Enterprises Limited. Is that correct?
Correct.
So what are you doing in this role as in Andrew Poplett Enterprises Limited?
Providing independent healthcare estates advice.
And what do you mean by that term, independent health estate advice?
It very much depends upon the client and what they are looking for. Generally, it has developed into acting as an authorising engineer for both specialist ventilation and water for multiple NHS trusts and some PFI private healthcare providers.
We'll come on to discuss what that term authorising engineer means, but apart from the aspects of your work that involve being an authorising engineer, what other tasks do you undertake?
In the early days of the company, I provided general advice and experience on running and setting up hospitals or healthcare facilities.
And would you do anything else within your role within the company?
No.
If I could ask you just to have your actual statement in front of you and to look to paragraph 3 on page 98, please.
Paragraph 3 on page?
Paragraph 3, and in the top right-hand corner it should say page 98.
Looking at a printed copy, so forgive me, but yes, paragraph 3 within this role.
Thank you. Yes, within this role, and if we can look down, perhaps 2/3 of the way down, you'll see a sentence beginning, I now provide independent, impartial and bespoke consultancy services. See that?
Yep.
You say, I now provide independent, impartial and bespoke consultancy services such as system auditing. What do you mean by system auditing?
System auditing is a primary role of an AE to ensure that the management systems for the control of ventilation are being appropriately provided.
And when you say AE, you mean?
Authorising engineer.
Turning to paragraph 3, there's then a reference to personnel assessments and awareness training. What does that involve?
Before an individual can be appointed as an AP, authorised person, they need to be assessed or their competency established by an independent party, that being the authorising engineer. So I undertake assessments of individuals who want to be considered either by themselves or by the organisation as an authorised person and assess their competence.
And you continue saying that you conduct compliance reviews and action planning. What does that involve?
It's part, again, of the auditing process, having identified where there may be a non-compliance or a shortfall. I provide advice or recommendations as to how that should be addressed and the manner and timescale in which it should be addressed.
And you continue in your statement saying that you guide clients through the maze of NHS, HSE guidelines, legislation and compliance. So is this a highly technical area?
It certainly can be, yes.
And what advice would you be giving to the NHS?
It very much depends upon the circumstance for which I've been asked to advise or be retained. As an authorising engineer, I would advise on all aspects associated with either ventilation or water with any given site.
So within your self-employed role that you've told us about, how frequently are you utilising guidelines, legislation, etc., existing within the ventilation area?
Daily.
And just to be clear, what subjects in particular is it that you're advising clients on?
Specialist ventilation and water.
You've used the term a number of times, authorising engineer. Is that a technical term within the industry that you work in?
It is a term defined within HTM00 core standard as an independent advisor for organisations to provide specialist advice.
So in practical terms, what would you be doing as an authorising engineer?
I would be undertaking compliance audits, assessing individuals for certain posts, principally authorised persons, and advising the trust or client on design reviews, either at concept stage of design or reviewing designs once completed.
And approximately how many NHS bodies are you acting as authorised engineer currently?
It varies over time. At present, I would estimate that it's around 30 to 35 trusts.
Thank you. Now, within your statement, you mentioned that you're registered with a body called the Institute of Health Estates and Engineering Management. That's at paragraph 4. Is that often used with the acronym IHEM?
It is.
So what is IHEM?
IHEM is a professional body similar to the Chartered Institute of Building Services Engineers, which covers building services generally. IHEM is specific for healthcare.
And you also mentioned that you're a founder member of a body called the Specialist Ventilation in Healthcare Society, is that correct?
Correct.
So what is the society?
The society is basically an open to anybody within the ventilation engineering field to share experience, best practice, and at times develop supplementary guidance notes. It was founded by Malcolm Thomas, who's lead principal author of the last 3 iterations of HTM, as it's an unfortunate term, but talking shop to discuss and debate issues that we come across and areas that need clarification or supplementary guidance.
So, formed by Malcolm Thomas, and effectively a forum so that individuals working in this area can meet and discuss issues relevant to best practice?
Yep.
Just to be absolutely clear on your expertise and the assistance that you can provide the inquiry with? You've obviously outlined within your statement areas of expertise in relation to design, commissioning and maintenance of ventilation systems. But you've also mentioned various legislation and legal principles at points in your statement. Am I right in thinking, though, that you're not a lawyer? And within that, you're not seeking to give any form of expert legal opinion?
Definitely not.
So should these really be viewed as observations to assist the inquiry? So, for example, when you make reference to legislation such as the Health and Social Care Act, if I was to ask you to outline specific sections that about various propositions, would you be able to do that?
No.
Where does your understanding of that legislation come from?
From 35 years' experience of dealing with it.
And is various points of legislation mentioned within technical guidance that you work with?
At times, yes.
If I could move on then and just ask you some questions about general principles of ventilation and to try and really focus on those within a hospital environment. What is ventilation at its most basic level?
The provision of air in its very basic form, intended to either dilute contamination generated within the space, provide a suitable, safe and comfortable environment for undertaking an activity that's being proposed within that space.
And why is that important within a hospital?
Within a hospital setting, ventilation in some areas can play a role in minimising the risks or reducing the risks of cross-contamination or infection.
You mentioned some areas there in your answer. Is it fair to say that some areas are more important than others in a hospital?
In terms of clinical outcomes, yes. But it very much depends upon how the space is used as to its criticality in terms of ventilation requirements.
What do you mean by it depends how the space is used?
For example, an office space that isn't a patient area, isn't being used for any clinical activity, still needs to maintain compliance to building regulation requirements, still needs to provide a comfortable environment for staff to do their job, but it will not have a direct impact on patient outcome. If you have an operating theatre that is inadequately ventilated, you will increase risk of infection as a result of that lack of ventilation.
What are the potential consequences of some of those areas of getting the ventilation system?
Again, it's driven by the criticality of the patient group. In extreme circumstances, it can lead to very severe consequences up to and including fatality of patient. In less serious environment, it may lead to uncomfortable working conditions.
If I could ask you about both natural ventilation and then mechanical ventilation. The inquiry's heard evidence in relation to both those concepts already, but what's your understanding of natural ventilation?
Natural ventilation is a means of providing ventilation without the use of external mechanical device. Now, it can be in its simplest form an openable window, or it can be an engineered solution relying on the stack effect or Bernoulli effect of vertical air ducts and drawing of air across to stimulate either convection or forced air from a natural source.
When we're talking about natural ventilation, at its most basic level, it would be opening a window.
Yes.
But there could be more complex natural ventilation solutions.
Yes.
Can you have natural ventilation in areas of a hospital?
Yes.
And if I could just ask you to look at your statement again, paragraph 25 on page 108.
Yep.
the second line down, second sentence, so paragraph 25, page 108, second sentence, you say, in certain circumstances, natural ventilation may be the best option. See that?
Yep.
In what circumstances could natural ventilation potentially be the best option in the hospital?
Natural ventilation is, generally speaking, the most energy efficient and therefore cheapest to run. However, it can also be affected by a myriad of issues and climate conditions, internal temperatures, external conditions, locations of windows, size of opening, all of which can have an impact on its predictability of performance. So where it is a low risk area, an office again, as the example, it may be perfectly acceptable to provide ventilation by means of openable windows. However, where you have areas where you want certainty of performance, you would generally utilise either forced or mixed mode ventilation to deliver that.
You mentioned the term mixed mode. What do you mean by mixed?
Mixed mode is a combination of both natural and forced ventilation.
And you indicated that you would want mechanical ventilation if you needed certainty of performance. So can you assist the inquiry in terms of areas of a hospital that you would need certainty of performance? What are you talking about?
Any area where ventilation performance is critical. The obvious and most frequent ones are operating theatres, isolation suites, where you are trying to either protect an individual from the general atmosphere or protect the general environment from a patient, i.e. infectious or neutropenic, but also where ventilation is critical to equipment performance. So certain imaging areas, CT scanners, MRI scanners, gamma cameras, et al., all can require specific environmental conditions for optimum performance. We also use ventilation in terms of controlling exposure limits of workers and indeed patients to potentially harmful substances where local exhaust ventilation comes into effect.
Am I right in thinking from your evidence that there's areas where you could quite safely use natural ventilation and there's areas where you would clearly need to use mechanical ventilation?
Yes.
Are there grey areas in the middle?
Almost certainly.
Could you give the inquiry any examples of such grey areas?
One of the difficulties with any healthcare design is that it is designed for one function and invariably clinical practice changes over time. When clinical practice or clinical usage changes, that can have an implication on the ventilation requirements. So an area that was originally designed to be naturally ventilated would then not be suitable for natural ventilation, and indeed vice versa.
So if I could now ask you about mechanical ventilation, what do you mean by the term mechanical ventilation?
Mechanical ventilation is the term used for delivering a forced or ventilation solution. So a given volume of air into given areas for the purposes of either contamination dilution, fresh air provision, or isolating aeromicrobiologically one space from another.
And in terms of the system, how are you forcing it?
Normally through either a fan or what is called an air handling unit.
Another term that's cropped up during the course of the inquiry is the term specialised ventilation systems. Is that a term you're familiar with?
Yep.
What is a specialised ventilation system?
Specialised ventilation system I would define as a ventilation system which is critical to the effective operation of a given area.
So can you give some examples of situations where specialised ventilation would be required?
Operating theatres, isolating suites, down to hydrotherapy pools, or indeed LEV systems, so safety or fume cabinets, autopsy dissection tables, woodworking machinery within the estates department. There's a whole host of areas where it would apply.
I've got you noted as having mentioned one issue being dilution of contaminants in relation to mechanical or specialised ventilation systems. Is that correct?
Correct.
Can you just explain, what do you mean by that term, dilution of contaminant?
Either through the process that is being undertaken or by the very presence of individuals within a space, every human being sheds skin scales, bacteria constantly. Within this room currently, everybody is giving off skin scales. Those skin scales can carry bacteria and in some cases virus. And whilst they are perfectly safe under normal circumstances, if you have, for example, a patient on an operating table, do not want to introduce that contamination to the wound site. The more people that are in a space, the higher the potential aeromicrobiological load is, and therefore the greater the need for effective dilution.
And in terms of dilution, can that be more significant for some patients in a hospital than others?
Certainly.
Could you give any examples?
The most obvious would be that if a patient has a weakened immune system, either as a result of disease or by a result of treatment, and are more susceptible or vulnerable to airborne contamination, then it is more important to keep those areas well ventilated and well diluted to maintain patient safety.
So important in relation to immunocompromised patients? And have you come across the term neutropenic patients before?
I have.
What does that mean?
Neutropenic is basically the extreme end of immunosuppression. If a patient is immunosuppressed, they may have a weakened immune system, but it still is there in some degree or shape. Full neutropenic patients effectively have no immune system, is my understanding as an engineer. I am not a microbiologist and would never claim to be.
And as an engineer, why do you understand that dilution of contaminant might be important for neutropenia?
Because the introduction of those contaminants can cause infection to those patients.
Can ventilation systems also assist in isolating spaces?
Yes.
And can you just explain what do you mean by isolating?
If you have a patient who is infectious, then it is essential that that infection doesn't spread beyond that patient or as far as is reasonably practicable. To that end, we use ventilation as one of the control measures to limit the airflow of any airborne microbiology from that patient to surrounding areas.
And just in terms of those airborne issues that you were discussing there, if I can ask you to look at paragraph 14 of your statement, please, at page 104. Paragraph 14, page 104, 3 lines down in the second sentence. Do you see a sentence beginning, contaminants basically fall into 3 broad categories?
Yep.
Paragraph 14, page 104. Contaminants basically fall into 3 broad categories of airborne risk. These are viruses, bacteria, and fungal spores. Again, as an engineer, what's your understanding of those concepts, viruses, bacteria, fungal spores?
Viruses tend to be extremely small particles. They generally live for relatively short periods of life outside of a host. One obvious exception is COVID. However, they are generally very small, live for short periods of time, and generally still travel within a particle, water droplet nuclei or water droplets to transmit airborne from one patient to another. or indeed from a patient to a staff member. Bacteria are, again, equally very small particles, can live all over the body in different areas. Even when they are in the areas where they do no harm, they are not a problem. However, they can travel outside of the body. Normally on skin scales is the area for airborne infection through bacteria, or indeed airborne to hard surface and then contact transmission. But again, generally very small particles, relatively short-lived outside of the human body. Fungal spores, when we're talking about airborne particles, are relatively large. We are still talking between 1 and 3 microns in size. To put that in context, a human hair is between 70 and 100 microns in diameter. But fungal spores can live for very much extended periods of time and can travel very large distances once released from their source, and again can cause infection.
And as you've explained, one aspect of ventilation is to try to seek to dilute those contaminants.
Yes.
I can ask you to look on within your statement to paragraph 20, please, on page 106. You say there at paragraph 20, my reminder for this is the phrase, the solution to pollution is dilution, with the aim to make sure that there is dilution of any contaminant that's developed within the space to a safe level. What do you mean by the term a safe level?
It's very difficult to quantify to a specific number, as it were. There are within chemicals and certain other airborne contamination agreed levels or work exposure limits for some issues governed through the Health and Safety at Work Act, the Health and Safety Guidance 258, and scheduled on Health and Safety Document EH40, which defines safe exposure limits for contamination. However, there is also the issue of unregulated activity. Coronavirus, for example, does not appear within AH40 currently, where ventilation is there to minimise the levels, not necessarily eliminate the levels.
So you mentioned health and safety legislation. That's one aspect of reducing things to a safe level. But we'll come on and talk about a whole range of guidance that exists in relation to ventilation systems in hospitals. How would that guidance link into that phrase you've used, a safe level?
The legislation requires organisations to do everything that is reasonably practicable, maintain a safe working environment. So that's where it would come to that ventilation plays a key role in maintaining that safe environment.
And in terms of maintaining that safe environment, the inquiry's heard already evidence in relation to a whole raft of things that a ventilation system can do. So one is air changes per hour. Is that a concept you're familiar with?
Yep.
And so can you just explain to the inquiry what's meant by air changes?
Air changes per hour is the number of, or the volume of air present within a room and the number of times that that whole room volume is changed. It is, however, not as straightforward or as simple as that, because it requires whole room dilution. So the air must be appropriately distributed throughout the space to ensure that the total volume of air is effectively replaced by each air change. The rule of thumb that is utilised is that for every air change within a room, 63% of any residual airborne contamination is removed, providing that no additional contamination is released and that the room has effective whole room air scrubbing.
So just so I'm understanding that, you said as a rule of thumb, every air change is going to reduce matters by 63%. So if we calculate that on, say for example, there was 4 air changes, how much would that be reducing the contaminant by?
Now you're asking me to do maths, which is, I would need a pen and paper for, but basically it's 63, the first air change removes 63%, the second air change would remove 63% of the remaining 37%, so by the time you get to, and the number I do know off the top of my head, 6 air changes removes 99.8% of any residual airborne contamination. Individual air change rates and cleaning rates, I would need a calculator to calculate.
So 6 air changes takes you to?
Effectively close to 100% clear.
And you've given us the formula that we can do the maths ourselves, but it's 63%, and then that repeats and repeats, and
provided no additional contamination is released.
Another concept that the inquiry's heard about is flow rate. Are you familiar with the concept of flow rates? Can you explain what's meant by a flow rate?
Flow rate is generally either taken in meters cubed per second, which gives a volume flow rate, or meters per second, which is a velocity flow rate. You can also measure it in litres per second, should you wish. Rather than using cubic meters, you can use litres. It is a expression of the amount of air that is transmitted through either a given duct at a known cross-sectional duct gives at a velocity gives you a volume flow rate, or indeed a volume flow rate from a grill you can use to then calculate if there are 6 grills and they are all doing 1 cubic metre a second, the room is subject to 6 cubic metres a second of supply ventilation.
Are they both ways of measuring how you'd be diluting contaminant within a space?
You can't calculate air change rates or air changes per hour without the volume flow rate, because it's the volume of flow rate plus or against the size of the room gives you a number of air changes per hour.
You need to know the flow rate and then you can work out the air changes per hour.
Correct.
The inquiry's also heard evidence in relation to pressure differentials that you have within various parts of a hospital, positive, negative, or balanced. Can you just explain your understanding of positive pressure and why you might want that in a space in a hospital?
Positive pressure is when an area, typically a room or suite of rooms, is kept at a higher pressure or pressure differential to the surrounding areas. The most typical area where this would be used would be for a neutropenic patient isolation facility, where you want to filter the air coming into the room at a given volume and maintain that clean room, clean air environment as far as practically possible whilst the room is in use. So the pressure cascade, you'd keep it at a positive pressure so you wouldn't get leakage from surrounding areas into the room. And when doors are used to get in and out, the airflow path remains from the protected area or clean room to the surrounding area, be that a lobby or a corridor.
So for an isolation facility, you need that to have positive pressure. And you mentioned that that would then mean that that space would be what you called a clean space.
Yes.
And again, can you assist the inquiry with this concept of moving from a sort of clean air to a dirty space? What do you mean by that?
The principles of healthcare ventilation is that you always want the air to move from clean to less clean. We tend to shy away from the term dirty until it gets into a dirty utility where we accept that things are dirty. But generally, we are interested in air paths that flow from clean to less clean.
So then in terms of the converse of that, if we think about a negative pressure, why would you want that in a hospital?
In the simplest example, if you have a WC, do not want any odours or melodious activity being transmitted out into the surrounding space. So it's under extract ventilation only, and that keeps it under a negative pressure differential to surrounding areas, which gives no escapage of odours. The more health-specific environment would be a protected patient environment for infectious patient, where you do not want the contagious infection getting out of the room, so the room would be kept under negative pressure to surrounding areas for the same basic principles as you would do odour control in a WC. But obviously the consequences are potentially more serious.
And then the final concept would be balanced pressure. Why would you want that in areas of a hospital?
Balanced pressure is generally where neither is of particular importance or where you need to try to contain an area but you cannot have it. You want both. You want it to be both positive and negative. Balanced is an option. Most relevant example I can think of is probably an infectious disease theatre. Within an operating theatre, you want a positive pressure and air to flow from the wound site, from the point where the patient is being operated on, outside to surrounding areas, clean to less clean. However, if that patient has an airborne infectious disease, you do not want to be pumping that contamination out into the surrounding areas. But equally, that patient is undergoing a surgical procedure, so you don't want contamination from potentially outside the area coming in to affect the patient. Therefore, a balanced pressure theatre would be the approach that you would take.
In your evidence, you mentioned that the rule of thumb, 63% reduction for each air change. Where does that come from?
My understanding was it was established as part of the original Lidwell report and investigations into healthcare ventilation within operating theatre.
So whenever you talk about the Lidwell report, are we talking about a Dr. Lidwell? And what report did Dr. Lidwell write?
He wrote a report in 1972, 74, I always get those two mixed up, that basically looked at and did research onto infection, post-operative infection rates within patients at different ventilation and the role that ventilation plays in those infection rates. And his research is the basis for the minimum ventilation rates that are still used today.
And just to be clear, what's your understanding of the conclusions reached by Dr. Lidwell in his report?
My understanding is that the report demonstrated that around 16 to 17 air changes per hour saw a improvement in infection rates if spaces were ventilated at or above that level.
And although that research was focused on operating theatre, are the principles applied more widely?
Yes.
Has that approach essentially become standard practice?
That is my understanding, yeah.
And is that research still effectively being used and applied today?
Yes.
Now, we'll come on and look at this in more detail, but you'll be familiar within Health Technical Memorandum that there's tables of air change rates for various spaces. Are you aware of how those tables have been produced?
Not specifically, no.
We've discussed the concept of diluting contaminants. Would it also be possible within a hostel to treat such areas by filtration?
Yes.
But what would that involve?
Filtration is a means primarily of removing particulates from the air. It can be as simple as filtering the air coming in from outside to a given standard, to filtering air leaving a space to remove particulates. You can also filter through not physical filtration, chemical reaction, certain odours and gases, although generally they are only applied in highly specialised areas of healthcare. Generally speaking, filtration for the majority of areas is today governed by the specific outdoor or external air quality of a given geographic location and the desired internal air quality required to safely operate specific healthcare activities. That then gives you a filtration grade that needs to be applied to achieve that level of performance. You generally filter initially to protect the equipment used to move the air, or it is a coarse pre-filter that filters air through the unit and maintains longevity and efficacy of the plant, through to final filtration that is designed to provide the right environmental conditions or internal air quality for the clinical environment.
So when we're talking about filtration, it can be used to effectively clean the air of certain microbes?
Yes, certain particulates.
And in relation to that concept of filtration, is that always fixed within a system, or can there also be mobile filtration units?
You can utilise mobile filtration units, have become far more prevalent within the last 2 years, but generally speaking, the efficacy of a in-room air cleaner or recirculating filtration unit is not a replacement for dilution ventilation, because it doesn't remove odours or gases, it will only filter particulates.
Just so I'm understanding that clearly, it's not generally a substitute because it's only filtering the particulate. Is that right?
In my opinion, it is not a substitute for dilution ventilation. It does only filter particulates.
If I could ask you to please have in front of you from Bundle 1, Document 10, which is at page 968. So is that a document headed up Appendix 1, Typical A plant layouts? Do you see that?
Yep.
And what do we see in the top diagram?
That is a graphical representation of a typical ventilation system and air handling unit serving an operating theatre.
If we start in the top left-hand corner, we see intake. What's happening in the top left-hand corner?
Right. When you're assessing ventilation and performance of ventilation, the assessment actually starts before the air intake. So you need to make sure that the area where you are drawing the air from is safe and suitable. You would not, for example, want an extract louver immediately beside an air intake louver, because you would be drawing contamination that you have removed from the area straight back into the area by means of the intake. You would also generally assess the intake area or area immediately around the air intake to ensure that it was free from external contamination, rotting vegetation, bird fouling, etc. Once you get through the air intake is equipped with a weatherproof louver to minimise the risk of rain or water ingress to the air handling or ventilation system. It is also equipped with what is called a vermin guard, which is a mesh, normally metal, between 6 and 12 millimetres in size, to prevent large contamination or indeed wildlife getting into the air intake area.
So just to be clear, what we're talking about here is there's fresh air coming into the intake, is that right?
Yes.
And you said that there has to be an assessment of effectively the air quality where you're drawing that air from?
Yes.
And that's then going into the system, and you've already clarified that there's various louvers to stop ingress of vegetation or animals or the like. So once the air is drawn in, we see that there's a reference to an attenuator. What's that?
If I can just complete the air intake, if it is not completely self-draining to prevent water ingress, then it should be fitted with a suitable drain so we do not get any ponding of water within that air intake section. I mentioned earlier fungal spores. Fungal spores are of themselves ubiquitous. They're all around us all of the time, but they generally only become seeded and give off and spore when they are subject to moisture. So it is very important that we keep ventilation systems as dry as possible to prevent them supporting or encouraging any proliferation of fungal contamination. From the air intake, if it is either self-draining or has a drain fitted, there is then an attenuator which is designed to prevent noise transmission from the plant back into the general area. It's also colloquially known as a silencer. So it's there to prevent noise pollution leaking out from the plant back to the general environment around the air intake.
You've drawn the air in, and then effectively there's a process so that the noise is reduced.
Exactly the same on your car exhaust. It has a silencer to prevent the noise of your engine being transmitted. If you blow your silencer, you realise just how noisy your car is. It's exactly the same for an air intake attenuator. It prevents noise transmission from the air handling unit back out into the general environment. From the attenuator, you then go through a motorised damper, which is intended as a shut-off device. So if you are working on the air handling unit or you turn the air handling unit down, it prevents air coming in from outside and turning the fan blade whilst a maintenance technician is working on the fan, or indeed air blowing through the air handling unit when it's not desired. From the motorised damper, you then go to a fog coil, which is a preheat, sometimes also called frost coil, and it is there to prevent any air that hits the primary pre-filter from containing moisture or freezing in the event of very cold, wet or foggy conditions. If a filter becomes wet, again, it is the primary location where you capture particulate matter. You don't want it getting wet because that will again encourage proliferation of microorganisms, but you also don't want it to freeze because that will cause it to have physical damage and potentially collapse, and therefore you would be taking unfiltered air into the main air handling unit. You then have the fan section, which basically
just before we come on to the fan, I just trying to think, so that the air's come in, it's been silenced, moisture's been taken out of it. There's then a reference to a primary filter. So what's happening at the primary filter stage?
The primary filter is removing particulate matter to a relatively coarse standard. Typically, you can filter it to a very high standard if desired, and it is there to protect the other mechanical elements and devices of the air handling plant. So it stops your fan getting dusty, it prevents the heating coil, cooling coil or heat exchangers clogging up with dust from outside.
Then we see next to that we've got the supply fan. What's it doing?
It's moving the air.
And how do you determine what specification of supply fan you need?
You would select the fan based upon the required airflow performance of the ductwork, taking into account the volume of air that you are looking to deliver to each room and the acceptable velocity of that air through the duct distribution system.
Does the type of fan that you need in its performance depend on the overall system, including the ductwork you've designed?
It's an integral element thereof, yeah.
Again, we'll come back to this, but it is really, although it's a lot of component parts, you've got to consider the whole system when you're designing it.
Yes.
Once the fan's turning and the air's been drawn through that, we then see a reference to a run-around coil. What's a run-around coil?
All air handling units now, by legislation, are required to employ some degree of energy recovery. The idea of healthcare ventilation is that we do not recirculate the air, we recirculate energy.
So why wouldn't you recirculate it?
Because you would either need to filter it to a very high grade to remove gases and odours as well as particulates. So we rely on fresh air dilution rather than recirculated air, because generally we live in a temperate climate and it is more efficient to use dilution ventilation rather than recirculated ventilation. The runaround coil can actually be one of 3 typical heat recovery or heat recuperator devices. It can either be a runaround coil, a plate heat exchanger, or a thermal wheel. The runaround coil is basically a metal finned radiator, for want of a better term, that there is one within the exhaust duct and one in the supply duct in the location indicated within the air handling unit, and water or another medium is circulated between those coils to take heat energy or potentially cool energy from the exhaust air and deliver it back into the supply air. So it acts as a preheat or energy recovery device, minimizing the amount of energy that is required from the secondary heater battery or principal heater battery that comes later in the unit.
So if I can just ask you to pause there, you mentioned a concept of a thermal wheel. Is a thermal wheel different to a runaround coil?
Yes.
How do they differ?
Right. Can I do these in order just to keep them straight in my mind? Runaround coil is a coil in the supply, a coil in the extract. You circulate water through the coil. There is no direct contact or risk of leakage of air from the supply to the extract because it is via a second medium, i.e. the water. A plate heat exchanger is where you have the supply air coming in and passes through a multiple plate matrix which has exhaust air going in the opposite direction, and you get thermal transmission between those plates. Again, the air streams are not designed to cross, so you have minimal risk of any crossover of exhaust and supply air, although, as with any manufactured device, there can be an element of leakage between those plates. The final option is a thermal wheel, which is, in basic terms, a spinning perforated disc which cycles through the supply air and then through the exhaust air. Normally the units, in fact, for a thermal wheel, they have to be mounted one on top or one beside each other. And as the thermal wheel slowly rotates, air that passes through from the exhaust transmits its heat into the thermal mass of that wheel, but when the wheel then rotates into the supply air, that heat is given up into the fresh air coming in. Again, thermal wheels can use both heat exchange and cool, but it is basically an energy transfer device. Primary difference with a thermal wheel is that because of its very nature and design, and you have to leave enough space for the wheel to spin, there is a small percentage of leakage possible between the supply and exhaust. So if you were exhausting air from a potentially highly infectious environment, thermal wheel would not be an appropriate means to transfer heat. Would want something that minimised the risk of that transfer. In general usage, thermal wheels have a very low proportion of leakage, one to the other, supply to extract or extract to supply, and are therefore deemed acceptable within the majority of healthcare environments.
If I can just be clear, what are the risks associated with using a thermal wheel in a hospital?
There is the small risk of crossover air moving from exhaust into supply, but probably from my perspective and practical experience, the biggest problem with thermal wheels is that they need to be maintained to quite high standards and levels of cleanliness to employ their efficacy. So to get the maximum heat transfer, the thermal wheel must be kept free from debris and contamination. If it doesn't, and it does become blocked, not only do you lose efficiency of energy transfer, it can also significantly impact on airflow.
In your view, would it be appropriate to use a thermal wheel in relation to an area of a hospital that would be dealing with immunosuppressed patients?
Personally, I would not recommend it.
Why not?
Because of the risk of potential cross-contamination and the amount of downtime that is needed to maintain and clean it.
Thank you. If we could then just return to the diagram on 96, please. I think we've dealt with everything up to the runaround coil. You could assist us with what's referred to as the cooling coil and eliminator.
After we've recovered as much energy from the exhaust air as we can, the air then passes through a cooling coil. The cooling coil can have two effects. It can be used to reduce the temperature, fairly obviously, but it can also be used to remove moisture from the air where humidity control or relative humidity control is required. The eliminator is fitted to the downstream face of the cooling coil to prevent moisture travelling beyond confines of the drainage system. As I mentioned within the air intake and indeed within the recuperator, drainage systems are required because moisture can condense out of the air at that point, and we want to remove that moisture from the airstream as quickly as possible and not allow it to pond or pool within the air handling or ventilation system. So the eliminator plate forces the air through what is effectively a chicane and drives moisture down, so it runs down into the drip tray and the drainage system that is shown on the diagram. Having gone through the cooling coil, it can then be necessary to pass through a heater battery. Heater battery, as the name suggests, would increase the temperature of the air, but in increasing the temperature of the air, you can also dry the air out, so it is a further addition to the control of humidity. What isn't shown within the typical air handling unit in this diagram was in previous versions was the provision of then a direct steam lance or humidifier, which can add moisture back to the air should it be necessary or required under the environmental matrix conditions. Once you've gone through the humidifier, and the order of those components, cooling coil, heating coil, humidifier, are critically important. And if you get them in the wrong order, they don't work.
I can just be clear, what do you mean by a steam lance or a humidifier?
It's a point of direct steam injection into the airstream that provides moisture into the air without altering its temperature.
And why might you need that?
Because if you want specific humidity control within a space, for example, the quality of image received from some CT scanners is dependent upon the environmental conditions within the room, including humidity. So the clarity of picture can be influenced by the relative humidity within the space.
Thank you, Mr. Poplett. I think I cut you off whenever you were about to tell us about the exact sequencing that needs to exist.
The exact sequencing is important. It must be cooler battery, heater battery, then humidifier if you have a humidifier. Humidification is generally not widely used within healthcare, and certainly is generally limited to specific environments where humidity control is of critical importance. Those are generally burns units or large open wound operating theatres where For example, the chest cavity is open for a prolonged period of time and you don't want the wound to dry out during the procedure, which leads to subdermal scarring. It used to be that we controlled humidity very closely because of the use of anaesthetic gases, some of which were explosive. And we wanted to control the humidity to minimise the risk of static electric discharge. We no longer use those anaesthetic agents, and therefore humidity control for explosive purposes is less of an issue. However, there is some emerging evidence to suggest that direct microelectric shock during cardiac surgery could be an issue where humidity control is again considered necessary. At the moment, that is not the case. Once we get through the humidifier, we then go to the secondary filter. That is where we can take the air in terms of its particulate content down to a level that is suitable for the patient environment, or clinical environment which we are serving. It then goes through a further motorised damper, which again is there. So if we turn the air handling unit off, we don't get any backflow from the rooms up through the unit, and it effectively isolates the air handling unit whilst working on it. Through a delivery attenuator or silencer, again removes noise transmission from the plant down into the clinical space. Where it's passing through a fire barrier, or the soffit in this case of the drawing, goes through a device marked FD, which stands for fire damper. That could be a fire damper or it could be a fire smoke damper. There are a difference between them. Don't know whether you want me to go into that level of detail. It then gets delivered to the clinical environment via the ductwork. You will see from the layup prep, in this design, there was clearly a need for a different temperature control within layup prep to the main theatre. Therefore, it has what would be described as a reheat or trimmer battery that is mounted remotely from the air handling plant, provides individual temperature control on heating to the layup prep as opposed to the operating or anaesthetics room in this diagram.
So what's the trimmer battery then at the end doing?
It's a reheater, so if you want the layup prep to be 2 degrees higher than the operating theatre, then the trimmer you supply air at the right temperature for the operating department, and the trimmer battery does that final increase by 2 degrees for the layup prep room.
And you've mentioned at various points duct work. Can you just be clear in this diagram, where are we seeing the duct work?
The grey material that is throughout the drawing, it's the means by which we transmit the air.
And then in the bottom of the picture, both on the left and the right hand side, we see the word extract written. What should we understand that means?
Those would be at the points within the rooms where we extract air, so we provide extract ventilation at low level within this environment or typical layout to ensure a clean air path across from the supply grill over the patient area and extracted at low level, or within, and the same within the anaesthetics room to make sure that any contamination within the room doesn't get drawn back up to the ceiling. It gets exhausted at low level, at floor level.
And what would we see through the extract grill? What would you need there to make the system work?
You would typically have ductwork again leading back up to the plant area, then either goes through an extract air handling unit, as I've described with the thermal wheel, a double deck arrangement with the supply unit, or it could be extracted by a separate independent extract fan. The extract fan itself is built up from a return air filter to protect the fan itself from any particulates that are removed from the operating theatre. It then passes through the fan, through an energy recovery device, the other half of the run-round coil, to then before it gets discharged through normally a further exhaust attenuator and to an exhaust louver.
Am I right in thinking if we boiled all of this down, you've got the fan drawing air in, there's then various processes where the air is treated, and then you have either a fan or some other process that draws the air back out of the space?
Yeah.
In relation to other aspects that could form part of a ventilation system in a hospital. The term chilled beams has been used at various points in the inquiry. But what's your understanding of a chilled beam?
Chilled beams fall, there are two types of chilled beam, passive and active. A passive chilled beam is in effect a radiator, but instead of heat, it puts out cool. It is a radiator type arrangement, normally ceiling mounted, where warm air rises within the space through convection. It comes into contact with the chilled beam, it cools that air down. That air then drops through convection back down into the room and is replaced by further warm air from within the room. And so it is a basic convection cycle device. You can also get active chilled beams, which are exactly the same as a passive chilled beam, but can include a degree of fresh air supply. So there would be a ducted supply air delivered to the chilled beam to provide an element of fresh air dilution, and it would then cycle through the chilled beam as previously described. You can also get, if you use refrigerant, chilled beams for both heating and cooling. Sometimes referred to, and I believe in one of the documents, as a comfort unit. These use refrigeration cycle as well as the convected air current approach to either heat and cool the air when required.
Just to make sure that I'm understanding things, at its most basic level, a chilled beam would be about cooling the air in a space. You could have a more complicated arrangement that both heats and cools the air within the space.
Correct.
And the system may or may not have some form of fresh air involved.
Correct.
In your opinion, are there any particular risks associated with the use of chilled beam technology in areas of a hospital where mechanical ventilation is required?
My personal belief, and it's reflected within the HTM, is that chilled beams are not appropriate for use in treatment clinical areas. The reason is twofold. First is that in terms of cooling air, you will naturally condense moisture from that air. That moisture does promote the proliferation of microorganisms. So we don't want air mixing with water, and certainly not water that isn't drawn away quickly, because it would promote or sustain microbiological proliferation. The other issue with chilled beams is that they are highly effective and very good in terms of energy usage, but they do require good maintenance to keep them operating in a satisfactory condition. Where you have a clinical environment, you do not want maintenance personnel going in with ladders and tools and equipment more often than is absolutely necessary, because without any disrespect to the maintenance technician, they are equally a source of potential contamination and risk to the patient and disruption to the clinical activity.
So you mentioned that they would need a lot of maintenance. What type of maintenance are we talking about?
They would need inspection and cleaning at least quarterly.
And you mentioned that you wouldn't advocate using chilled beams in treatment clinical areas. Just so I'm clear, what do you mean by that within a hospital?
Within a typical district general hospital, I would consider that as bedroom spaces, ward area, patient overnight spaces, or treatment spaces where ventilation rates were critical.
And again, just to be clear, in terms of the risks, what risks, if any, are associated with chilled beams potentially being used where there's immunocompromised patients?
Well, as I say, they naturally, as part of their function, condense moisture out of the air. That moisture goes into drip trays, drainage trays, and then is either drained away through gravity or by condense pumps. As soon as you introduce moisture and potential wet surfaces into that environment, if you have fungal or microbiological airborne activity, it will tend to proliferate within that moisture.
You'd mentioned a term, a comfort module. What do you mean by a comfort module?
It is basically a chilled beam but has heating as well as cooling capacity.
I'd like to now ask you some questions just about filters and filtration. What is a high efficiency particulate filter?
A high efficiency particulate filter, or HEPA, is a grade of filter which will take out a very high percentage of very small particles.
And what type of particles?
It doesn't differentiate on the type of particle, it differentiates on size of particle and the capacity or efficiency of capturing those particles. So if you look at a typical filter, EPM1 at 50%, or the equivalent of what used to be called an F7, that will capture 50% of particle sizes 1 micron in size. A HEPA filter will capture particles down to a much smaller grade of size, typically 0.3 or 0.4 microns, and will capture between 99.9% and 99.9998% of those particles from the air. HEPAs still do not filter out gases or odours. They are, as the name suggests, high efficiency particle filtration.
Again, just thinking back to what we've seen in the diagram, is that really coarse filters that we saw within that standard diagram?
No, the coarse filters would be normally, and in previous terminology, G2 to G4, they are coarse filters that will take out relatively large particles at relatively low efficiencies. The secondary filter will take out finer particles at a higher efficiency, capture far more of them. A HEPA is the top end of the spectrum, which will take out the highest percentage of down to the smallest grade. A HEPA will also filter out large particles. It won't just filter out the little ones, it filters out to a far finer grade. So the analogy I would use is it's the difference between a colander, a kitchen sieve, and a muslin cloth. You've got different grades of filter capturing different sizes of particle.
Can you have a portable high efficiency particulate filter system?
Yes. However, they do not provide any fresh air. They only provide cleaning to the air that's within the void. So again, they shouldn't be seen as a replacement to dilution ventilation. They can remove particles that are within the room.
Would there be any issues associated with them being used in areas that had immunocompromised patients?
One of the challenges with using air cleaning devices, particularly where you have extremely vulnerable or critical care patients, is space. There are umpteen machines that are working on keeping those patients, monitoring their conditions, keeping them alive. They're on potentially a ventilator, they have infusion pumps, they have monitors. There's all manner of equipment within those rooms. To add to that, a recirculating cleaning device for the air takes up floor space, adds to the heat load, adds to the noise and the difficulty that both clinical communication can have, but also other than the highly critical care areas, it's actually good for the patient to be able to go to sleep. If you have a Henry Hoover running in the background constantly, it is challenging for people to sleep through that. So recirculation devices introduce noise directly to the clinical area, which is not ideal for the patient.
In your experience, should there be a requirement to add a portable high efficiency particulate filter to a space that already has a high efficiency particulate filter fitted to the ventilation system?
Generally speaking, no. If the air change rates are adequate, you shouldn't need supplementary HEPA within an area that already has HEPA filtrated air.
If you saw a space whereby there was what you refer to as a portable or a mobile HEPA filter, and there's already a HEPA filter there, what questions would you be asking?
Why?
And what conclusions might you be able to draw after those investigations, or is that impossible to say?
It would very much, I would imagine that it's been driven by a clinical request, either through IPC or the clinicians. I would want to understand what their understanding is that the unit contributes to that patient environment.
And what types of patient environments would require a high efficiency particulate filter?
Most commonly immunocompromised or neutropenic areas would certainly require it. Other areas are within operating theatres where UCV canopies or ultra-clean ventilation canopies are deployed. For a number of the Royal Colleges have identified that certain surgeries should only be undertaken where UCV theatres are operating. UCV theatre is a variant from the example shown in Bundle 1, Document 10, which instead of the grills going directly into the room, they deliver the supply air into what we call a air plenum. That plenum is fitted either with single or multiple recirculating fans that take the air, supply air, add it to air that's been extracted from the room and push it through a tertiary third stage HEPA filtration level. Generally speaking, UCV theatres will operate at somewhere between 400 and 600 air change per hour under the canopy volume and provide HEPA cleaned, if you like, recirculated air within the void. But it is supplementing already fresh air dilution ventilation provided by the air handling unit and extracted in the way described in the typical layout.
My fault, Mr. Poplett. The UCV, C maybe canopy, V maybe ventilation. I missed the U.
Ultra. Ultra.
Thank you.
Everybody, that's just before 11:30. I was going to move on to a different chapter of questions, so if your lordship's minded to take a break, now may be an opportune moment.
Seem appropriate. As I said, Mr. Poplett, plan to take a mid-morning break. Clock tells us a little before 2:30, so if we could try and be back by 1:45. Mr. McGregor.
Thank you, Mr. Poplett. Just a few questions still dealing with the diagram that we've looked at previously and the questions that I've asked you. In relation to thermal wheels, you mentioned that you wouldn't recommend that they're used in certain areas of hospitals. Is there any guidance in relation to such issues?
No.
What's your view based upon?
My view is based upon experience and my assessment of potential risk and disruption or maintenance requirements of the various different systems.
And similarly, in relation to chilled beams, you suggested that you wouldn't recommend that they're used in areas, for example, involving immunocompromised patients. Is there any guidance in relation to such issues?
Within the current HTM, they are specifically recommended against their use unless it is subject to specific risk assessment and approval by the Ventilation Safety Group.
So that's for latest guidance, which I think is 2021 onwards, is that correct?
Correct. So
what was the position under the previous guidance?
I would need to double check, but I believe that they were still not recommended for clinical areas.
Certainly, if we're thinking in the period before 2021, would you have recommended their use in those areas we've discussed?
No.
And why not? What's your view based upon?
Chilled beams are incredibly effective and useful in certain environments. They are highly energy efficient and very effective in stable environments. Office buildings where you have sealed windows and no fresh air, it's great. They are frequently deployed and highly effective. Where you have a dynamic clinical environment, such as within healthcare, and you have issues of microbiological and airborne contamination risks, I don't believe they're an appropriate solution.
Thank you. And if we could return to the diagram that we've been looking at, which is in bundle 1 at page 968. So that's the diagram of the ventilation system in the operating theatre. See at the bottom left and the bottom right, we've discussed the extract grills. Where would the air be being extracted?
It would be extracted to outside. So they would, as part of the ventilation strategy, you are putting in a certain amount of air into the area to achieve an air change rate. Some of that air you want to leak out to surrounding areas to provide the clean air path, the clean to less clean environment we discussed earlier. Other areas, because of the sheer volume of air we're talking about, you want to extract directly from the space because you don't want that contamination either transferring to the surrounding areas, or it's just a case of we've got enough air leaking out through the natural air path and air leakage rates to provide the right pressure cascade or pressure differential, and therefore the remaining is extracted and passed through the extract element of the air handling unit. Energy recovery is affected on it, and it's then discharged back to the atmosphere.
And if you had a build-up of moisture at the extract grill, would that be problematic?
It would be less problematic than if it was within the supply system, because the extract grill and ductwork is by its very nature under a air path that is away from the patient area. But it is not an area where you would want microbiological activity to proliferate, because when you shut the systems down, they effectively fall under neutral pressure, and it would be possible to get contamination back out the extract duct into the area.
And I think that the final issue is just in fairness to you, we discussed Dr. Lidwell's formula, and you talked about 63% dilution, and then it would be 63% on that. Again, I appreciate you don't have a calculator, but if we did look at those numbers, would it possibly be with one air change, we'd be looking at 63% dilution?
Yes.
And then possibly if we modelled that on, then with 2 air changes, you're bringing that down, the base figure would be approximately 37, with approximately an 86% dilution rate.
From the original, yes.
From the original. And then so on, at 3 air changes, you would be at the 13.69, approximately 94% from the original.
Yep.
Does that make sense?
That
plausibly?
sounds correct. As I say, the only proviso or two provisos is that that must be with full room distribution. It can't be in the left-hand corner and out the left-hand corner and not touch the rest of the air. And it can't be used if you are continuing to release contamination into the space.
And if we continued that on, at 4 air changes would be down at approximately 5.07 and touching approximately 98% from the original contaminant.
Yep.
And if you model it on, you get down to, as you said, at 6 air changes per hour, you're talking approximately 9. If I can ask you to return to your statement, please. So paragraph 9, which is on page 101 of bundle 6. Paragraph 9, you begin to explain about health technical memoranda and other guidance such as health building notes. Can you just explain to the inquiry, what are you meaning by this guidance?
HTMs, HBNs are guidance issued by the Department of Health to inform those involved in construction and operation of healthcare facilities, the technical and spatial issues associated with their design and operation. So they are broken down in terms of HTM into 8 categories, one for each engineering or specific technical discipline, 7 in reality, with the 8th being the anything that doesn't fit in the first 7 approach. And HBNs are documents that are suited down by clinical activity. So you will have an HBN for mortuaries, you would have an HBN for X-ray departments or imaging, you will have a HBN for acute inpatient areas or outpatient areas, or so the HBNs are driven by clinical activity, the HTMs are driven by individual engineering or service disciplines.
Within the health technical memoranda, one general health technical memoranda, is that correct?
You have the 00 core standard, which is basically how all HTMs should be managed and considered. That's the umbrella HTM, and under those you have the individual engineering or subsections.
And in terms of those subsections, as you explain in your statement, you'd, for example, have a separate health technical memoranda for water and then one for ventilation.
Yes.
So how then, if you have that guidance, the health technical memoranda, what exactly are the health building notes and other associated guidance? How do they fit together?
The engineering or HTMs talk about services such as ventilation or water or electrical. The HBNs talk about clinical activity and spaces. So HBNs also cover the technical building aspects. So it will cover things such as sanitary appliances. So what your wash hand basin should look like, what's the difference between a wash hand basin and a sink, what toilets are, what the spacing of those are, if you've got disability or accessible facilities, how they should be configured and operated. So HBNs talk about either building discipline or clinical activity disciplines. The HTMs talk about the engineering services, so ventilation, water, etc.
If we just take as one example, if we look in bundle 2, please, document 10, page 832, we should see a health building note 0402 critical care units.
Yep.
Is this specific guidance relative to critical care units?
Correct.
look on to page 835, see the preface there about health building notes, which states health building notes give best practice guidance on the design and planning of new healthcare buildings and on the adaptation / extension of existing facilities. They provide information to support the briefing and design process for individual projects in the programme. Do you see that?
Yep.
So is that your understanding about the purpose of this type of document?
For health building notes, yes.
If we then look on to the next page, please, to page 836. See on the left-hand side, there's the bold heading, Other Resources in the DH Estates and Facilities Knowledge Series. And then there's a reference to Health Technical Memoranda. These Health Technical Memoranda give comprehensive advice and guidance on the design, installation, specialised building and engineering technology used in the delivery of healthcare. They are applicable to new and existing sites and are for use at various stages during the inception, design and construction, refurbishment and maintenance of a building. And then does it say all health building notes should be read in conjunction with the relevant parts of the Health Technical Memoranda series? And is that your understanding of how the guidance should?
Yes.
On the right-hand side, that there's a reference to Activity Database, ADB. Do you see that?
Yep.
Just before we read it out, what's your understanding of what Activity Database is?
ADBs provide, if you like, a starting point for any design. So the ADBs will cover typical rooms, layouts, what those rooms should contain, how those rooms should perform. You would then take the ADB as a skeleton framework to then look at the specific clinical requirements of a specific HBN, or indeed any limitations by reutilising or refurbishing existing buildings to apply or fill in the gaps or tailor it to be specific for the clinical activity that is being planned.
And physically, how would you find it? Is it a hard copy guidance like a health building note?
It's not an area where I have current sort of practice in doing, but my understanding is that it is a software system which is accessible through NHS, which gives you the information in an auditable and adjustable format.
And you say you don't have current experience. Have you historic experience of using Activity Database?
ADBs are generally used when creating room data sheets or RDSs when you are planning a project at the design concept stage. As I say, it gives you your starter for 10 that this is what we would typically expect to find and require. It is then tailored by the specific clinical requirements as detailed in the HBN, or if an HBN is not specific for that area, a particular clinical practice. As I'm sure you'll appreciate, clinical practice develops more quickly than HBNs are written around that clinical practice. You have to invent something before you can write a book about it.
So just to be clear, you mentioned the term room data sheets. What is your understanding of room data sheets?
When you undertake a project, you will typically find that every room within that scheme will have its own individual room data sheet. That room data sheet will capture the fundamental elements of what that room exists. It will very frequently include the environmental, how many sockets, what medical gases, how many outlets would be in, what air change rate you might expect from the ventilation system, down to lux levels that you would expect from the lighting, provision of fire alarms, a whole raft of individual specific technical elements that principally are covered under HTMs, but are specifically scheme captured in the RDS room by room.
Just so that I'm understanding things, a room data sheet and the activity database, are they the same thing or are they different things?
The ADB is where you start your room data sheets from. You then tailor your room data sheets specifically to the clinical activity that you are looking to provide. So an RDS is unique to that room in that project. The ADB, I hate the acronyms that the NHS use, is used as the starting point where you would say, well, typically we want the toilets to have this level of ventilation, that level of lighting, a toilet pan, a wash hand basin, a coat hook on the back of the door, etc., etc. The RDS is then, in this particular application, is that the right level that we want in that room in this circumstance?
My understanding is the activity database effectively a database of options you could then create a room data sheet from for an individual space?
It's the starting block for an RDS, yes.
Okay. Just returning to bundle 2 at page 836, activity database, it states the activity database ADB data software assists project team with briefing and design of their environment. Data is based on guidance given in the health building note, health technical memorandum building component series. Room data sheets provide an activity-based approach to building design and include data on personnel planning relationships, environmental considerations, design character, space requirement, and graphical layouts. Now, again, what's your understanding when you've used activity database of what's meant by environmental consideration?
It's what environmental conditions you are requiring within that space to undertake the planned clinical activity.
Would it include issues relating to engineering and ventilation in particular?
Yes.
Would it include levels of detail, including air changes per hour?
Yes, where they're applicable.
Again, just so I'm understanding this, if you go into the activity database and create your room data sheet for a specific space, that will automatically be drawing out values that are set out in things such as health technical memoranda and health building notes.
It will be drawing out the typical values. You still need to check that those typical values are appropriate for the clinical activity to which you are planning the space to be used.
Just a starting point, but it would then have to be reviewed. So if we just return still on page 836 at number 2, schedules of equipment / components are included for each room, which may be grouped into ergonomically arranged assemblies. Schedules of equipment can also be obtained at department and project level. Fully loaded drawings may be produced from the database. Reference data is supplied with ADB that may be adapted and modified to suit the user's project-specific needs. What's your understanding of those terms, that it can be adapted and modified?
It's exactly as I've described. You would take the ADB and convert it into a project-specific RDS.
We could then move on, please. Still within bundle 2, but this time to go to document 11, please. The document 11 on page 859. That should be the health building note 0401, supplement 1, isolation facilities, infectious patients in acute settings. You see that?
Yep.
And have you seen this before?
Yes.
So, again, if you just explain, what is this? It's obviously a supplement, a building note, but why would a supplement?
A supplement is generally issued where there is a requirement for a new kind of room or new kind of clinical environment that hadn't been previously or suitably covered by an existing HBN. So in terms of the isolation facilities, this was developed because there were issues with isolation facilities within NHS settings, and it outlined a strategic approach to take when considering and designing isolation facilities. Historically, there have been and still remain isolation facilities that are known as switchable. So you give user control, predominantly to a nursing staff member, to make the room either positive or negative depending upon the nature of the patient that they were treating. Nurses have a hard enough job and are overworked far too much already to worry about knowing ventilation standards and knowing the difference between positive and negative ventilation and when such ventilation should be applied to different patients. So the HBN, when it was produced, it is specifying either different grades of isolation facility, but it introduces the concept of what is known as a PPVL, or positive pressure ventilated lobby, and that is a design concept which is intended to be appropriate for either infectious or neutropenic patients without any change in its engineering approach other than the grade of filtration that is provided.
Giving very specific guidance on a particular aspect of a ventilation.
Yes.
And again, if we just look on, still within Bundle 2, the same document, page 864, we should see the executive summary of what is then set out in the detailed notes. So page 864, this health building note sets out practical guidance on how to provide safe, effective isolation facilities for infectious patients, source isolation, that are simple to meet the needs of most patients, general wards. Then it goes on to state what the guidance is going to set out. See that?
Yep.
And then at the bottom it says it's advised that this health building note to be read in conjunction with, and then there's a list of guidance that follows thereafter. So if we put that to one side, and if we return to your statement, please, so that would be in Bundle 6, page 101, at paragraph 9, please. Paragraph 9, you set out a series of bullet points. You start with the Nuffield functions and designs of hospitals. Why did you include that?
It provides basically just a history of when ventilation in particular started being recorded and considered as a specific consideration within healthcare.
And then you work through, so there was the operating department and HBNs. Was that a specific HBN from the 1960s?
Correct.
We've then covered off the work done by Dr. Lidwell in the 1970s. And that then takes us up to what you've called DV4 in 1983. What was DV?
DV4 was a Department of Health publication that covered ventilation for operating departments and was the precursor to HTM 2025.
And then from 1994 onwards, we see reference to the Health Technical Memorandum 2025. Is that correct? And really then you've set out further guidance. So we have the Health Technical Memorandum 0301 in 2007. How did that differ, just in general terms, from Health Technical Memorandum 2020?
It was part of a move from the 20 series, as they were generally known, through to the O series of HTMs. So it was a reformatting. It was, as I understand it, government initiative to try to slim down the number and volumes of guidance provided, and was particularly focused on the fact that the procurement methodology was changing within healthcare, and it was more focused on the output rather than the technical content of any design.
And then we've got the current version, the Health Technical Memorandum 0301 from 2021. Is that the most recent guidance?
That's the most recent guidance.
Effectively, from the 1990s onwards, on a periodic basis, it's being updated.
Yeah.
And why is that required?
Technologies change, practices change, clinical activities change. Generally speaking, as you go through the various iterations, we have started to include far more examples of clinical activity than were originally included. So originally it was based very much around operating departments and operating theatres. As you will see from when you look at Appendix 2 in 0301-2007, we've listed far more than just operating theatres as areas where critical ventilation would apply. And again, if you look at the latest iteration in 2021, we've included an entire chapter, now Chapter 8, that covers specific clinical activity areas where ventilation plays a part. And we've also expanded the aid memoir, which Appendix 2 forms.
So, Health Technical Memorandum, who produces it?
It is produced under the control or authority of the Department of Health. They appoint a normally team to actually do the work. They appoint a lead author, and that lead author, in my experience on the ventilation standard, then compiles a group of individuals from varying backgrounds to contribute to its review and production. So if you look at the very start of the latest HTM, there is a list of around 40 names of individuals who were involved in the authorship of it.
And you've used the term we. Have you been involved in the production of Health Technical?
I was involved and sat on as a committee member of the latest iteration of the HTM.
And the inquiries heard evidence previously that the Health Technical Memorandum, although it applies in England and Wales, it's produced on what was described as a four nations approach with input from all nations in the United Kingdom. Was that your experience?
Yes.
Again, can you just perhaps mention that there's a lead author and then there's a team of people? Who's in that team of people that are assisting with producing the guidance?
It is a wide selection or variety of those working in the industry with specific knowledge. Some come from representation from named organisations, institutes or societies. So in terms of the ventilation process, we had members representing the Chartered Institute of Building Services Engineers. We had people representing manufacturers, people representing commissioning and balancing engineers. We had people representing the SVH Society and authorising engineers. We had representation from IHEAM. We had representation from HSA UK, as it is now, PHE as it was then. And having gone through the drafting process, drafts of the final document were then circulated to a wider group of Royal Societies and other institutes for comment, review, before forming the final document as it is published.
In terms of the input, would clinicians have input?
Yep.
Microbiologists?
Definitely.
Infection prevention and control?
Yes.
And I think you describe it in your witness statement as being a broad church of disciplines that come together to create the guidance. Is that correct?
Yes.
Who's the guidance aimed at?
Predominantly, the guidance is aimed at engineers and those responsible for designing, in terms of HTMs, the aspect for which they cover. They are also aimed at those who operate them and maintain them. So different parts, if you look at the current HTM, it is broken down into a two-part document, Part A and Part B. Part A is intended for the development, design, construction, commissioning of systems, ventilation systems in the case of 0301. Part B is aimed for the operation of all ventilation systems, whether they are brand new or historic. So the Part B is written to apply to any ventilation system, irrespective of the date of its design. Part A is obviously aimed at new designs undertaken from the date when publication occurred.
Again, just so I'm understanding, you mentioned that it would be aimed at engineers who are working in this space, both in design. Would it also be aimed at those who are responsible for owning and managing healthcare facilities? So in England and Wales, would that be healthcare trusts?
Yes.
And again, just so I'm understanding this, is it more than just simply a technical guide written by engineers for engineers?
I think it very much is depending upon your role as to how much you would read and how much you would need to comprehend and understand. It should, at the very highest level, be understood that there are guidances and specific standards that need to be met. Does everybody at that level of an organisation need to understand all the nuances that go into the design of a ventilation system? No, that is not practical or feasible. However, for those with specific requirements of design and operation, they need to know. And at that point, it's for engineers specifically. But it is hopefully written in language that easily explains to non-engineers why ventilation is important and where ventilation needs to be considered.
Thank you. In relation to the Scottish Health Technical Memorandum, the inquiry heard evidence from a Mr McLaughlin who works for Health Facilities Scotland, and he described the Scottish Health Technical Memorandum in the following terms. He said that those not close to the issue might assume that they're an instruction manual handed out by the government. This is not the case. They are the health service's interpretation of the responsibilities it has under the applicable legislation, regulation, codes of practice, government policy. Would you agree with that?
Yes.
If I could ask you to please look within Bundle 2, this time to Document 2. So Bundle 2, Document page 90.
Thank you.
You see there what you've referred to, I think, as OO, so Health Technical Memorandum 00, Policies and Principles of Healthcare Engineering in 2014 edition.
Yep.
What's the purpose of this document?
This document provides an overview of the management structure for all of the other HTMs.
So if we look on to page 93, should be headed up in the top left-hand corner, preface, so page 93. You see on the left-hand side, third paragraph, beginning, healthcare providers have a duty of care.
Yep.
Do you see that? So it says, healthcare providers have a duty of care to ensure that appropriate governance arrangements are in place and are managed effectively. Health Technical Memorandum series provides best practice engineering standards and policy to enable management of this duty of care. You see that? So is that one of the objectives of this guide?
Yes.
We then look on, please, to page 95. Page 95, on the left-hand side, the final paragraph in green, it says Activity Database ADB.
Yep.
And it says the Activity Database, data and software, assists project teams with the briefing and design of the healthcare environment. See that?
Yep.
And again, is that consistent with what you've told us already, that really you're looking to the Activity Database to assist with briefing and design in relation to ventilation?
Yes.
And it continues, data is based on guidance given in the health building notes and technical memoranda. It says for ADB inquiries, there's various contact details that are provided. So again, I think as you've already said, within the activity database, the values there are going to be based upon the guidance, the health building notes.
Yes.
If we then look on to the next page, to page 96, which should have in the top left-hand corner executive summary. Do you see that?
Yep.
This time, page 96, on the right-hand side, under the bold heading, aim of the guidance.
Yep.
It says the aim of HTM 00 is to ensure that everyone concerned with the management, design, procurement and use of the healthcare facility understands the requirements of the business critical building and engineering technology in order to ensure optimum safety for all who are present in the building. You see that?
Yep.
Now, one of the things Mary's interested in knowing is, in terms of this guidance, is it just general guidance or is it comprehensive guidance in relation to ventilation?
Well, HTM 00 doesn't cover ventilation specifically. It is an overview of, if you like, all of the HTMs. The HTM for ventilation, 301, and to a degree the HTM 00, fulfills both minimum standards and best practice in depending upon which area you are looking at and which area you are considering. So I believe with HTM 00, the core standard states that everybody needs to be familiar with and aware of the requirements of this and follow it to ensure that there is a safe environment for the facility to operate. In terms of specifically for ventilation, it covers, as I say, depending upon the individual clause or the individual application, could be in places considered as best practice and therefore potentially open to derogation, or it could be in some places considered as minimum standard, therefore I would position not subject to derogation.
We'll come on and talk about the derogations, but I'd be interested in your views in terms of that paragraph, whenever it states that really what we're looking at here is ensuring optimum safety for all who are present in the building. Why is that reference included in the guidance?
Because within hospitals, we don't just have to keep the patients safe, we also have to keep the staff safe and ensure that visitors and anyone who utilises the premises can do so safely.
It then continues in the next paragraph, only by having knowledge of these requirements and the organisation's board and senior managers understand their duty of care to provide safe, efficient, effective and reliable systems which are critical in supporting direct patient care. And this understanding is expected that appropriate governance arrangements would be put in place, supported by access to suitably qualified staff to provide this informed client role which reflect these responsibilities. What's your understanding of that term, informed client?
My understanding is that a health board is responsible for the operation of an incredibly complex, at times, facility that not only deals with incredibly complex clinical issues, but also has with it technically challenging engineering and building elements. An informed client is to make sure that the client or board are fully appreciative of all of the elements that go up to make that safe environment. So you can't concentrate on only one aspect. You have to look at all of the aspects and how they interact with one another and what you intend to undertake clinically to provide and make sure that you can both provide and give assurance that that facility is safe and appropriate.
Thus far, I think you've covered off that this guidance, both 00 and specific guidance, would be relevant to engineers and it would be relevant to the board of the trust itself. Would other stakeholders in this area be interested in the guidance and whether it's complied with or not?
I would like to think that all stakeholders would be interested in it. Practically, the level of knowledge and commitment to read and quote it would be probably limited to those two groups. But yes, it is fundamental to the operation of the safe environment. So you wouldn't appoint AEs unless this document said you should really have AEs. You wouldn't have necessarily authorised persons. This document structures that you need someone in the organisation who is operationally familiar to a sufficient level of competence with the technical aspects of any particular engineering discipline. So it is applicable to everybody, it's accessible and open to everybody. The level of familiarity and involvement with this document is probably limited by practicality rather than restriction of access.
Would regulators potentially take an interest in the document?
Yes.
What regulators?
CQC.
Whenever you say CQC...
Care Quality Commission.
Any other regulators?
The Health and Safety Executive, although HTMs don't fall directly under HSE, they are considered by the HSE as a form of approved code of practice or best practice. So when they audit, they will check against both HSG standards, Health Safety Executive standards, such as 258 for LEV systems. They may also look at HTM 0301 to look at ventilation aspects specific to healthcare. And HTM certainly reference back to HSG 258.
And do you have any experience of dealing with the Health and Safety Executive in relation to documents such as the Health Memorandum?
Regrettably, yes.
And what interest, if any, did they take in compliance with the Health Technical Memorandum?
Their primary focus is on health and safety guidance, i.e. the HSG, the HSE published guidance. However, they are also interested in and utilise the HTMs as I say, a form of approved code of practice.
And is there any specific examples that you could provide to the inquiry?
3 weeks ago, I was involved in an HSE inspection regarding water systems, where the HSE inspectors were quoting and looking at both the HSG guidance and the HTM guidance.
And would your expectations be the same in relation to ventilation?
Yes.
If we can then look on, still within Bundle 2, within SHTM 00 at page 97, top left-hand corner, you should see users of the guidance. Page 97, providers of NHS healthcare and operating facilities in England will be the main users of this document. However, other stakeholders, including regulators and inspectors, may also be interested and will expect that this best practice guidance being followed, or that where this is not the case, healthcare providers can demonstrate how any best practice expectations are being met by equal and alternative means. Is that your understanding of this guidance? Is it best practice guidance?
As I've said, I believe that the HTMs in various elements serve as both best practice and minimum standards. Overall, I personally consider them as an approved code of practice. So in my expectation and experience, again, going back to the water equivalent, I would consider the HTMs to be of equivalent standing to L8 is in water. So it's not legislative, it's not mandatory in and of itself. However, you need to be able to demonstrate compliance or a reason for non-compliance and measures that have been taken equal or better than the standard. Again, I would just remind you, I'm not a solicitor, I am just an engineer.
Thank you. So if we could look on still within the same guide, this time to page 110, please. I think you'd mentioned it earlier today that it was in SHTM 00 that you see the concept of an authorising engineer coming into being. Is that what we see set out at paragraphs 3.16 and 3.17?
Yes.
You see at 3.16, the AE will act as an independent professional advisor to the healthcare organisation. The AE should be appointed by the organisation with a brief to provide services in accordance with the relevant HTM. Professional status and role required may vary in accordance with the specialist service being supported. What stage does an authorising engineer become involved at? Are they involved at the design stage, or do they simply come into being once the healthcare facility is up and running?
That is a very good question and not easy to answer. An AE, I believe, as an AE, has value to offer at the pre-design stage, so the concept stage of a healthcare facility development. They certainly have a role to play in the design and design review to ensure that the proposed design meets the requirements of the HTM. They have a role in ensuring at validation that the systems actually deliver what the design and intent and clinical output spec was to be achieved. And they then have a function to play in terms of ensuring the ongoing operation and ultimately decommissioning and disposal are undertaken again in conformance to the requirements of the HTM. So when to involve an AE is very much driven by the complexity or the nature of the project development. As an AE, I would not expect to be involved in the designing, back to my original very simplistic project of a new toilet with a new toilet extract fan. Where you are planning a new respiratory illness unit or a new building within an existing estate or indeed a new hospital, then I would expect an AE to be involved at design concept prior to design to ensure that it complied in terms of the client, being an informed client, was asking the provider to provide what they actually required.
In your opinion, an authorising engineer should be involved as an independent person right at the start of a project for an acute hospital?
Yes.
Is that set out in any legislation or in any guidance that you're aware of?
No.
We then return, please, to page 110, this time at paragraph 3.17. It states that the AE will act as an assessor and make recommendations for the appointment of authorised persons, monitor the performance of the service, and provide an annual audit to the... Now, if we take those in turn, what's the reference here to an authorised person? What does an authorised person do?
The authorised person role is, in practical terms, a site-based individual with sufficient technical knowledge of the engineering discipline and the specific engineering installation on the site to manage the day-to-day operation of the ventilation system.
So does the authorised person come in once the facility is up and running?
Generally, yes, if it is a new facility. If it is an existing facility that's being extended or replaced, then the operational AP should normally be involved at the design stage in conjunction with the AE to ensure that the final project is maintainable and is suitable for continued operation post-project handover.
In your opinion, again, if we think of this example of building a brand new acute hospital, there should be both an authorising engineer and an authorised person appointed right at the start of the project.
There will normally be an AP, unless we are talking about starting a hospital from scratch. They normally come from an existing healthcare facility. So that AP will exist. They should be involved at design stage and at concept stage to ensure that the final design and therefore final project is maintainable, because that's going to be their role once the project has been finished in terms of construction.
And that's obviously your opinion, but again, is that set out in any legislation or any guidance as far as you're aware?
No.
If we could return to paragraph 3.17, just the final sentence, approximately 4 lines up from the bottom, states to effectively carry out this role, particularly with regard to audit, the AE should remain independent of the operational structure of the healthcare organisation. And is that your experience of being an authorising?
Yes.
Why do you consider it's important to remain independent of the healthcare organisation?
The designated person, and indeed duty holder above the designated person, is the employer of the authorised person. Individuals can find it challenging to tell their boss that things aren't being done properly or that they need to spend significant financial sums or resources onto a scheme. The AE is there to provide independent advice and assessment. All we lose is the contract if we upset the designated person or duty holder, but we have a professional responsibility to provide that independent assessment. The AP, being an employee of the DP, is in a more vulnerable position to deliver bad news.
And at the very bottom of page 110, we see various boxes with a rough chart. So we've got the designated person, an appointed senior executive at board level with assigned responsibility for the service. And then below that, we've got the authorising engineer, who's an appointed independent professional engineer. And then next to that, you've got the trust senior operational manager. So that's described as the informed client or the intelligent customer. You see that? And then below that structure, you've got the authorised person. That's an appointed qualified technical engineer. And then below that, you've got the competent person, described as assessed and qualified craftsperson. Is that right?
Yep.
Is that a rough organisational chart that you're familiar with, acting as an authorising engineer?
Yes.
Is that where you would sit in the hierarchy, that you're part of the chain, but independent from anyone that's in the direct designated person, senior operational management, and authorised person?
Yes, and in my opinion, and indeed as reflected in this chart, the important element is that as an AE, I have direct access to the designated person without going through a myriad of trust senior operational managers, as indeed the AP does, should it be necessary.
If we can now look on to Health Technical Memorandum 2025, so that's in Bundle 2, Document 3, so Bundle 2, Document 3 at page 163. Is this the original Health Technical Memorandum that we saw set out at paragraph 9 of your statement, which came in the 1990s?
Yes, it is one volume of 4 volumes that make up HTM 2025.
And this is the more specific ventilation guidance that you talked about in the suite of guidance?
Yes.
And look on to page 166, please. You see in page 166, top right-hand corner, this HTM was written. See that?
Yep.
It says this HTM was written with advice and assistance of experts in the NHS and industry. See that?
Yep.
So again, was it your understanding that really from the 1990s onwards, there was a collaborative approach to producing this type of guidance?
Yes.
We then look on to page 169. You see it paragraphs 1.4 and 1.5, so page 169, 1.4, it sets out what ventilation is. Ventilation is provided in healthcare premises, the comfort of the occupant buildings. More specialised ventilation will also provide comfort, but its prime function will be to closely control the environment and air movement of the space that it serves in order to contain, control and reduce hazards to patients and staff from airborne contaminants. Do you see that?
Yep.
And do you agree with that proposition?
Yes.
And it continues 1.5, ventilation systems in themselves present little danger to patients or staff. However, they do possess the ability to transmit hazards arising from other sources to large numbers of people. The danger may not become apparent until many patients and staff have been affected. See that?
Yep.
And do you agree with that proposition?
I do.
We can look on, please, to page 183. You see a heading called Minimum Fresh Air Requirements.
Yep.
Page 183, paragraph 3.15 states, for most applications involving human safety, the dilution of body odours is the critical factor in determining ventilation requirements, and where natural ventilation or full fresh air systems are used, all ventilation air will be fresh.
Yep.
And it continues, where odour dilution is the overriding factor, it is recommended that 8 litres per second per person to be taken as the minimum ventilation rate. However, this rises to 32 litres per second for rooms with heavy smoking. And is that still the general guide just for any space, 8 litres per second?
No.
But how's that been updated?
Building regulations currently specify a rate of 12 litres per second per person.
For any space, there's a
any space,
minimum
not healthcare
requirement.
Specific, education, industrial, office, how you like, it's 12 litres per second per person.
That would be the base level, as you've said earlier today in your evidence, for specialist areas in healthcare, there might have to be more. At this stage, in the
Apologies, John, can I just interrupt? It's 10 litres per second per person.
10 litres.
I've got too many numbers rattling around my head at once. And building regs are currently under review, which could change that figure again.
But at this stage, in terms of HTM 2025, do we find any prescriptive table that sets out specific areas with specific air changes?
Within the appendices of HTM 2025, particularly for operating theatres, air change rates were specified. However, they were specified in terms of litres per second based upon a standard size of theatre, which equated to an air change rate of 20 air changes. What was not specifically provided within HTM 2025 was an air change rate irrespective of the size of an individual clinical space.
And why wasn't that done?
I don't know. I was not involved at that point. I was still a junior engineer and wet behind the ears. It specifies for a standard size theatre the level of litres per second is required in each space of a operating theatre. If you make that theatre smaller physically, then you actually get more air changes than would be essentially necessary. And if you have a very large operating theatre space, you would have less air changes. I believe that is why when 0301 was updated in 2007, the move was made to air change rates, because air change rates are not size specific in terms of airflow to a room. They are governed by the physical size of the room, if that makes sense.
Again, if I'm understanding you, from 2007 onwards, as opposed to just having a flow rate or a litre per second, there's a move to the concept of an air change per hour.
Correct.
If we can look, please, within Bundle 2, Document 8, page 698. Bundle 2, Document 8, page 698. You see here, it's heating and ventilation systems, health technical memoranda, 0301, specialised ventilation for healthcare premises, and it's part A, design and validation. If we could look on, please, to page 702, which is the preface. Page 702, about health technical memoranda. It says engineering health technical memoranda give comprehensive advice and guidance on the design, installation and operation of specialised building and engineering technology.
Yep.
Again, would you agree that it's providing this comprehensive level of guidance for those in
Yes and no. It provides guidance which I consider comprehensive on the principles as to why we ventilate, what we're trying to achieve with ventilation. It does not, because it's impractical to do, provide specific guidance on every possible application where ventilation would be deployed. So the principles are comprehensive. Individual specific guidance on if your room's this big or that big, or you're going to do this or that different procedure, is not and cannot be comprehensive.
So still within the preface on page 702, just below the diagram, left-hand side, the paragraph, healthcare providers have a duty of care to ensure that appropriate engineering governance are in place, and effectively the Engineering Health Technical Memoranda series provides best practice engineering standards and enable management. Again, similar to what we saw in 25, reference to best practice. If we look on to page 704, bottom left-hand corner, who should use this guidance? This document is aimed at healthcare management, design engineering, estates management and operation. And again, that's consistent with what you've told the inquiry. If we look on to page 705, we see a series of acknowledgement. So we see the first person, Malcolm Thomas, I think you've told us about earlier, who you described as the lead author. What's Malcolm Thomas's background? Is he an engineer or is he?
He's an engineer.
Then we see a range of principal contributors. We see a principal clinical scientist, individuals from industry, and then we see main steering groups and working groups comprising representatives. Do you see that?
Yep.
We've got the Department of Health, Welsh Health Estates, NHS in Scotland, Health and Social Services Northern Ireland, a variety of bodies such as the Health Protection. So again, do we see bodies from throughout the United Kingdom having input into the health? We look on, please, to page 712. In the introduction section, paragraph 1.7, the bottom left-hand corner, page 712, paragraph 1.7. The sophistication of ventilation in healthcare premises is increasing. Patients and staff have a right to expect that it be designed, installed, operated and maintained standards that will enable it to fulfill its desired functions reliably and safely. And then there's a whole set of reasons for ventilation. It says the building regulation require that all enclosed workplaces be ventilated by either natural or mechanical ventilation. The following are some of the factors that determine the ventilation requirements of a workplace. You have human habitation, activities of the department. We see dilution and control of airborne pathogenic material. Again, I think you've covered that earlier in your evidence inquiry today. We see thermal comfort and a whole range of other requirements set out. Here.
Yep.
See at the bottom, mechanical ventilation systems are expensive in terms of capital and running costs. Planning solutions should be sought to take advantage of natural ventilation, provided the above criteria are met. See that?
Yep.
And again, is that consistent with the evidence that you gave this morning whenever you said you should consider natural ventilation because it's cheaper, but there might be requirements for mechanical ventilation in certain areas of the hospital?
Correct.
You look on one page, then on page 713, we see a table with ventilation that gives some application examples. It's got the requirement, the reasons, and then the application that you'd have to consider for that. So, for example, in the clinical space, really the reason for having ventilation is reduction of surgical site infection and source and protective isolation. So again, just to be clear, I think you covered this this morning, just to be clear, what's meant there by source and protective isolation?
It was when we were discussing either infectious or immunosuppressed neutropenic patients. So you are either isolating the patient from the surrounding environment, or you are isolating in either direction, positive or negative. The environment can cause harm to the patient, or the patient could cause harm to others within the general environment.
And as we see in the right-hand box, applications would be isolation units for patients who present a biological, chemical or radiation hazard to others, or isolation units for patients with the reduced immunity. If we look on to page 716, please. Bottom left-hand corner, paragraph 1.25 onwards, do you see a reference to specialised ventilation, which states in healthcare premises, certain activities will necessitate the provision of ventilation equipment, additional special features in order to achieve and attain specific conditions. These may be needed in order to assist with the treatment of patients or maintain the health and safety of staff. Precise reason for providing specialised ventilation will depend upon the indication. The list below indicates some of the more typical reasons. We then see a range listed, including A, remove, contain, or dilute specific contaminants. Look on it to page 719, please. On the left-hand side, you see a reference to natural ventilation. Paragraph 2.6 at the bottom, which states it is almost impossible to maintain consistent flow rates and ensure that minimum ventilation rates will be at all times. However, this variability is normally acceptable in such areas as office accommodation, staff areas, library/seminar rooms and dining rooms, where opening windows a design that facilitates natural ventilation will be provided. See that? There isn't any reference there to clinical spaces. Do you have any observations on that?
Generally speaking, within clinical spaces, you have patients who either have specific issues or vulnerabilities which could be airborne, or you are undertaking clinical activity which could give rise to that. I would therefore believe that the HTM is suggesting natural ventilation is not ideal where there are specific ventilation rates required to achieve an appropriate environment for healthcare. And if within this document you then refer back to Appendix 2, it will give you a list of those areas where specific ventilation rates should be achieved.
We could then look on, still within the same document, to page 723, please. (723), top left-hand corner, paragraph 2.56, which states natural ventilation is always the preferred solution for a space, provided that the quantity and quality of air required and consistency of control to suit the requirements of the space are achievable. If this is not the case, a mechanical ventilation system. See that?
Yep.
So in simple terms, is that the demarcation between?
Yes.
I'd ask you to look on, please, to page 777.
Sorry, Mr. McGregor, that was my fault. That last reference was to page 777.
It was we're going on to look at page 777. The previous reference was, I'll just go back, but I think it was page
723. Thank you.
Yes, Mother, it's page 723, paragraph 2.56.
Thank you.
I was moving on to look at 777. Lord Brady, that may be an opportune moment to break. I'm conscious that's just before 1 o'clock.
Well, we'll take a break for lunch and sit again at 2 o'clock.